Hi, welcome to AgileTD After Work. I mean, now in Germany it's midday, but in Japan it's already in the afternoon. So I'm very happy to have today or tonight, depends on where you are, Mesut, Durukal, and he's based in Japan. And he's now coming to the stage, and we will talk a little bit, and then he will run the presentation. Hey, Mesut, welcome.
Hi, Jose. How are you doing?
Fine, thanks. And you? How are you?
I'm good, thank you. As you said, it's already night here,
Okay.
so end of day.
End of day. What time is it now?
It's 6 o'clock, 6 p.m.
Oh, okay. That's fine. This is
Yeah, not too late. Yeah,
it's the time to get dinner in Germany, more or less. How this in
same,
Japan? The
same
same.
here. Yeah,
Okay.
around this time.
Okay. In Spain, you are already done with the lunch. So
I know. Last week I was in Spain.
yeah. Okay. 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 That's nice. So you're based in Japan. How long have you been living there?
It's 5 years now.
Oh. Okay.
Yeah, I'm living in Tokyo. I'm in Yokohama, very close to Tokyo.
Okay.
Yeah,
I
but
want
now
to.
I'm somewhere else. My wife's parents' house. It is next to Fuji Mountain. It's very high.
Okay.
And this is why my voice is a little bit different than usual. I have a sore throat, so it's still cold here. Summer
Okay.
is very late in this area.
Okay. Okay. So. Tell me a little bit about you. What are you doing?
Yeah, I'm a tester. It is almost 17, 18 years. I worked in different domains, different organizations, but I always did some quality assurance activities. Most of the time test automation, but of course not always. But yeah, this is what I'm trying to do, like designing test cases, trying to ensure the quality in the product that we are doing. And now I'm working for Indeed.com, which is a job seeking platform,
Okay.
and trying to ensure the quality again in the web applications that we have.
Okay. Nice. So, and you send a paper to the Agile Testing Days, and we
Yes,
ask you to do an online presentation. And we're very happy that
yes,
you accept that. And so let's start. I will share your
sure.
presentation, and then we'll go off.
All
So
right.
enjoy your presentation, and see you later.
Thank you so much. So again, hello everyone, and welcome to this amazing stream. Again, my name is Mesut Durukal, and as I briefly mentioned, I'm a quality assurance automation engineer. And finding bugs is an important part of our daily work because removing bugs means getting rid of the vulnerabilities or the weaknesses in the product that we are developing. But there is one other aspect, like not only finding bugs, as QA engineers, we always said that not only finding bugs and fixing them, but also avoid them in the first place, right? So this is what we will mostly talk about today, like making an analysis on the bugs that we found before, and based on that analysis, try to avoid them in the first place. And furthermore, doing this by the help of machine learning, right? Of course, nowadays in a presentation, you don't expect not talking about AI. So this will be a part of the talk as well. And at the very end, I will share you a case study where I tried to build a model for my bugs. Because the very straightforward way, and most probably in the first place, what you thought might be using some LLM tools or interfaces to develop your model. But in this case, I want to talk a little bit from a different perspective and building your model from scratch. So this will be a machine learning problem, and we will see how it goes. So let's get started. I will talk about, first of all, the even the preparations that we can do and even the mindset that we should maintain before starting doing analysis. And in the second part, some metrics that we can collect, because how can we do the analysis of bugs? We should decide about some metrics, and then based on those metrics, we can track our quality. So what kind of metrics we can track? This is what we will talk in the second part, and third part will be the machine learning part. So first of all, the introduction. As I said in the beginning, like improving the quality, of course, fixing bugs is one outcome of fixing bugs. But on the other hand, of course, they will provide a lot of insights to us. Like we can learn a lot from the bugs when we talk to them. I'm saying I'm talking to them because I believe there is a language that we can communicate with, which we can communicate with the bugs. It is like a natural language. Like whenever we talk with someone in English, in Japanese, in Turkish, whatever, we can talk to bugs in their language. And whenever we ask some questions to them, we will get some answers. What do I mean by this? Of course, it is not exactly the same way as we communicate with people, among humans, but it will be in different ways. But still, communication, building a communication channel to the bugs is very important. So what kind of questions I can ask to the bugs? Like as a good interviewer, I can ask 5W and 1H question, which are where did it happen? In which platform? On which operating system, on which execution environment. Why did it happen? Very important. Like, what are the root causes? Who triggered this issue, this bug? Like maybe an admin user, or maybe just an ordinary user, or a user who is using some particular cases or steps or a certain pattern. Or what is the reason? What happened? Like what steps I went through and what did I encounter, and how did it happen, again related to the steps I went through, and when, like maybe probably related to the phase in the testing stage or in production stage. So all these kind of questions are very important questions. And after getting answer to these questions, again we will be collecting several important information, because we will do kind of data mining, right? There's a raw data over there lying underlying the bugs, but we have to mine them. We have to collect the insights. We have to find important, insightful information. This is what we will try to do. But let me share you an analogy about collecting this information, or the steps to be able to collect this information. For example, let's suppose I'm staying in an airport and I'm waiting for my flight, but my gate changed somehow. So I should know this information, right? Otherwise, if my gate changed and I didn't know, then I would miss my flight. So what can be the reasons that I don't still know my change? Maybe they are not able to transform this information to me, like they don't have screens that I can check, or they don't have loudspeakers that I can listen. This is one way or one reason that I'm missing this information. So I did not see, I did not hear. So I'm talking about the visibility or the transparency problem. Maybe we can relate to the environment or the tooling that we are using. Second reason might be they are doing some announcements. I can hear something, but I don't understand what I'm hearing, because maybe they are doing this announcement in a certain language that I don't speak. So now we are talking about the data transformation in a different or bad format or bad channel that I don't know. So this is related to the formatting or the protocol that we are using to communicate with the bugs. And finally, maybe the announcement is there, and maybe even the language I understand, but data is too noisy. Like I can't really understand what they are saying. I can pick some words, but the full context I cannot understand. So now we are talking about too much noisy data, and the reason that we are not cleaning our data or extracting the relevant information from the raw data. So we will relate to these reasons later on, but let's see what we can do. For example, we talked about the environment or the tooling that we are using. So what we can do is maybe we can customize our tools and environment, right? For example, let's suppose I am using Jira as the issue tracking system, and there's a default flow, like it starts from a created issue, then it's in progress, and after in progress, then it's done and it will be closed. This is the default flow, but it's not granular enough to get enough information. Like I can add some more granularity by adding some more steps or status. Like maybe after new, I can add some more custom specific status related to bug lifecycle, right? It might be rejected, it might be deferred, it might be not reproducible, or it might be even already duplicated, so I don't have to work on this anymore. So by adding all this, by customizing our tool, I can already increase my visibility and the transparency. So we can already relate this to the analogy that I shared in the previous slides. One more thing I can do is we are talking about a continuous monitoring, right? So monitoring I can do every day by just opening the UI and performing my queries. But manual monitoring will not be easy by doing every day by manual. It will require a lot of effort, manual, human effort, and it will cause a lot of time waste. But if I automate this process, maybe I can develop some code, a very simple code or even a script, and I can run on my pipelines. It can automatically run every day, and in the morning I can already collect the query results, responses. And even parsing the responses, I can already extract the relevant information, important information from these responses. One last step. This data, these numbers are great. They're telling a lot of stories to us. But reading, again, raw data, raw numbers are not easy. So if we reflect these outcomes to some monitoring dashboard, some visual graphs, charts, it will be way easier to understand what's going on in our environments. We can easily see the trends, like if the bugs are going high, or maybe even we are violating some limitations, right? We can, on these charts, we can set some limits, thresholds, and if they are violated, then I can already get some notifications and alarms. So everything will be automated and way easier to eliminate the human effort. So these are some custom steps or the customization that I can do to improve the efficiency and the visibility of my environments. But what kind of information I can collect from the bugs? Let's a little bit talk about this. Because there are too many metrics that I can track, and maybe some of them might be not relevant, right? So I can focus on my goal and I can decide the relevant subset. For example, what's my goal? Is it just reducing the number of bugs? Or is it just reducing the number of bugs which are going to the production environment, which is basically the number of escaped bugs? Or is it maybe reducing the number of only the critical bugs? So first of all, what is my goal? I have to decide on this, and then I can pick the relevant or the related metrics. But in this part, I will share just some different metrics so that you can have an idea about different monitoring activities that we can do on the bugs. On this slide, we can see the distribution of bugs across their status, like how many percentage is already validated and already open, or the severity, like maybe most of the bugs are still in critical levels, high severity classes, and minor of them are the low classes. What we can understand from this graphs is again something we should think about. Like if most of the bugs are still open, and even the number of uh, bugs which are open is increasing, then we should think about it. Why? Maybe we have the limited resource, or maybe we are too busy to develop new features before getting rid of these bugs, issues. So after doing this analysis, we can take even some action items, like maybe sometimes it will be the time to stop developing some new features and first of all, getting rid of this technical debt. So after doing this proper analysis, we can even have some action items to improve our quality, not only the quality of the product, but also quality of our processes and our workflows as well. Another example, I like this one. For example, I have a, let's say, a microservices cloud-based architecture, and there are several microservices, and on which particular module or microservice or unit, I'm finding the bugs the most. Like let's suppose I have 50 services and half of the bugs are coming from a few services. then probably that's something wrong on those specific services, right? Maybe I'm skipping performing some specific type of test on those services, or maybe any other reason. But after I find this finding observation, then I can investigate more and try to find the root cause. But it will already give a clue about where I can start. So this is another example. A similar one, bugs per type, like most of the time, what kind of bugs I'm having. Is it mostly the functional bug or is it mostly related to documentation? So I can improve my relevant processes. Like most of the time, if I'm having security related bugs, then probably I have to improve my security tests, right? Or I have to inject some more security processes to my workflows. Maybe I can automate my accessibility verification activities. I can add to my pipelines. So depending on the situation and the observations that we have made, then we can again take some relevant action items to improve our processes. This is another example. Not only the pie charts, but also we can show some progress charts where we can see the bug detection rate. For example, in this sprint, we are finding very few bugs maybe, or too much bugs. So we can try to understand what is the reason behind. At this point, I want to make a notification or a heads up. Like if we stuck on some particular metric, like the number of bugs found by one person, that might be misleading. So we can do this analysis in a comprehensive way. Like if I'm checking only the number of bugs found by different members in the team, and of course I cannot do a performance evaluation based on these metrics, right? If one person is finding 10 bugs, the other person is finding 2 bugs, it doesn't mean that the second one is worse than the first. That might be misleading. But why I'm sharing all this, maybe we can combine with some other metrics to make a comprehensive study and relating with some other metrics and combining with some other outcomes, then we can find some reasonable or some beneficial insights and we can take our action items. Similarly, we can track the resolution duration as well. Again, as I said previously, like if our resolution rate is maybe getting lower, then we might try to understand, is it due to the resources that we have, or maybe is it due to the other tasks, more prior tasks that are hindering us to resolve these bugs. So we can try to understand the root cause again. And this is the one that I again shared before, where we can see the gap between the created bugs, new bugs, and the resolved bugs. So if the gap is getting higher, then maybe that is the point where we should stop developing some new features and first of all getting rid of those quality issues. Some other charts like table representation, this I also like. For example, in this way we can understand how many bugs are still open which are in critical levels. Like on this table I can see there is one issue which is open for more than 60 days, which is a long time. And normally it's 71. It is the highest criticality severity level. I'm using criticality and severity by in terms of each other, but normally we can decide this prioritization based on different aspects. So personally, what I do most of the time is deciding for a severity bug. I of course check the criticality, like how critical it will be if this bug happens. The other aspect is it might be super critical, but it might be super low low possibility. So the visibility or the possibility, like if it happens, it will be critical, but it will be barely happen in some very certain cases. Then still, even though it is critical, it might not be too much severe. So although I'm using interchangeably, normally criticality is a subset of severity, we can say, in general. But of course, you can follow different approaches to decide about your prioritization. A similar table, this time, the bugs waiting for validation. Like on this table, I can see two issues are resolved, but not validated yet. So in the previous one, I could go to the development teams to ask why it is not resolved yet. But this time I can go to the QA people to ask why they are still not validating this, right? If they are facing an issue, because maybe if the issue is resolved, is marked as resolved, it doesn't mean that the issue is totally fixed, right? Maybe the issue is still there. The developers think that they resolved the issue and they fixed it, but maybe that might not be the case. So it should be validated and it should be closed. So if it's not closed yet, then I can ask QA people to do, because otherwise, please do. Otherwise, we will not be sure that the fix is really working and we can close, because it might be still there, right? So in that case, we should reopen the issue. So not to lose too much time on that, please do this validation activities, and then we can conclude about the next step of the bug. Previously, I mentioned briefly mentioned about escape bugs, but I want to highlight this because this is important. Like we always said, early feedback, like right shifting left. So what is the reason? Because if we find the issues, or if we have the issues in the later stages, of course it will be more expensive, and it will be even more difficult to apply the fix on the working code. So maybe the architecture will be there, all the other modules are there, so changing the whole approach will be very difficult, and most of the time it will be very expensive. So we can have a dedicated monitoring on these escaped bugs, which are capable of going to production environment. And last part, machine learning. So I'm saying this collaborated intelligence because I believe that we have to perform these activities with a collaboration between the human and the machines, because yet we cannot fully rely on the results coming from the machine learning activities, right? Of course, most of the time it's very accurate. Nowadays, the AI algorithms, the LLM algorithms are very accurate. Their coverage are very high, but still, like we should maintain a human in the loop, and as the final decision maker, we should be there to just go on with the release or block the release. But before going on, I want to first of all make a very brief background about how machine learning works. It's very similar to actually how our natural intelligence works, right? For example, as a tester, human tester, if you ask me how I can test your system, my first step would be learning your system. Okay, I will test your product, but first of all, give me some time. And maybe even if possible, give me some documents. So I will go through them. I will read the requirements. I will read the specifications. I will do some exploration, and I will learn. This is the learning. This is the training stage, right? It will be the similar in the machine learning. We will give a lot of input, and it will develop a model. It will relate the inputs and outputs. It will reveal the relations between the input and output, and it will develop their model. And based on their model, they'll try to predict the outcomes for the upcoming incomes. As most of the things that human are doing, they are inspired by some natural things. Again, this machine learning is inspired by our natural learning process, and most of the algorithms work in a very similar fashion that we do. For example, on this slide, I'm sharing a classification model, which is a deep learning model. And let's suppose a cat is coming from far away. So I classify, learn, I predict what is coming. Normally, it's an object, right? But I understand it's an animal, it's a moving object. And first of all, I make a classification. Like it is not a huge animal, so it might not be a bear or a tiger, but it might be a cat or a dog, something like that. So this is the first part, right? So I'm using different layers, different features in different layers. So first of all, I use the size feature, for example. And then, based on some other features, by doing some further classification layers, finally I decide if the object approaching me is a cat or something else. So this is again very similar how the machine learning algorithms make their predictions. So in this problem, that I try to perform in my project is I will try to classify the bugs according to their severity levels. So we discussed about how we can decide about the severity. So there can be the criticality, the visibility, the possibility. But in this problem, I will try to do this by reading the bug's description, because of course, first of all, I will export all my issues from my issue tracking system, which will be Jira in this case. And then I will give the model the description of the bugs and the labels. Like this bug was labeled with severity 2, for example. The other bug was labeled with severity 1. So I will give all the inputs. And after the machine learning algorithm builds its model, then I will give some new bug description and I will ask it to decide about the label. So it's a supervised learning algorithm. In this problem, I had almost 900 bugs exported from Jira. It's a very small data set, I know, because normally for a proper learning, I need a very comprehensive data. But I wanted to use only the real data from my project. This is why I exported only the bugs from my project tool, and I had 900, and I had 3 severity levels. And one more important thing in this project is if it is severity 1, the highest severity level, then it's a release blocker. But otherwise, if it is not 1 or 2 or 3, like 1 or the other 2, then they are not release blockers, but they are some bugs which can be fixed after even we make the release. So this is an important decision I will utilize. What I'll do to solve this problem? First of all, pre-processing. We discussed about making a data clean, right? We discussed about effects of noisy data in the analogy that I'm sitting in the airport. So this is what I'm doing here. So if there is any punctuation or any other formatting that I have to do, this is where I do. I clean data and I remove what I don't need there. So the only information data is there. And then after that, I have to do the feature extraction. Like after I clean data, what I have is sentences, right? For example, when I ping this service, then I had 500 response code. This is the bug description. This is just a sentence. If I give the sentence written in English language, then the machine will not understand. I have to give this information in machine language. At first, we discussed a lot about using the proper language, right? So machines do not understand English language. They understand numbers, which are basically only ones and zeros, binary numbers. So this is converting sentences or any other format of data to numbers, numeric vectors, is the feature extraction in machine learning algorithms. And there are different ways to do that, but in this solution, what I did is just counting the occurrence of words in sentences. Like I have a sentence, and in the sentence, this is an apple, for example, I count each word. This word is happening only once, for example. So I have already one value for the first cell, right? And is again happening only once. And in my vocabulary, there are some other words. So which are not in this sentence will be marked with 0. So I will have a numeric vector already. So this is already the feature extraction. And after I have the feature extraction, I can use lots of different algorithms like k-nearest neighbors, naive Bayes algorithms, decision trees, random forests. So I tried most of them and I picked the most highest performing algorithm. So let's see some results. So this is the confusion matrix. It gives 73 accuracy. But in this PDF it's lost, but there was a biased representation. Most of my samples was marked as severity 1. So I don't want this bias. So I want to merge severity 2 and 3 together. So I want to decide if a bug is release blocker or not. So in this case, I have 2 classes, right? Instead of 3, because I merged 2 and 3. I have to decide 1 or not. So I have two classes, and in this case, I remove bias as well. The data distribution will be much more balanced. In this case, I had 82% accuracy. Still not perfect, I know, but this is a little bit difficult problem because even if we do a bug triage, I believe most of us are having bug triage on some particular cadence, maybe every week, every sprint. And there are some discussions around the severity levels, right? Sometimes I claim that this should be high severity. Some other people in my team claim that no, it is not. We can accept that it might be low. So there might be some subjective areas. So making the decision is not easy always in this problem. But again, this gives us an idea that it can already facilitate a lot my processes, and I can gain a lot of time by asking machines to make the first round of decision. But I have to again maintain the human in the loop. And before making the final decision, of course, I can have a human eye at the last step. Not only the classification, but also I can do the clustering as well. So I can decide which bugs are heaping together. For example, there are some certain keywords which are happening a lot on some different bugs, so that I can perform some clusters and I can collect those similar bugs together so that I will easily manage them, right? Maybe as I can assign those similar bugs to a certain team, or I can again make some management tasks much more easier in this way after clustering similar bugs together. So let's wrap up. We discussed the importance of making an analysis on the bugs, right? Because we find a lot of bugs, but most of the time we fix them, and we are happy that we are fixing the bugs, right? Because it's super cool. We are eliminating some issues, vulnerabilities. But is that it? Because there is a huge data over there. In time, after we fix bugs, find new bugs, fix those bugs, there are too many records over there. Why don't we use them? Just go over them and ask a lot of questions. Why did they happen? Maybe some of them already happened in similar ways. So if you asked before, maybe you would even have some action items and you would not have them similar ones again and again. You would already avoid them. So we discussed about the importance of this analysis, and we discussed about different metrics on which we can show the distribution of bugs by using different types of monitoring tools or charts or graphs. And finally, we discussed that we can make this process by the help of, or maintain this process by the help of machine learning. Again, not only this, like you don't, of course, you don't have to develop your model from scratch. You can use some tools. But this was just an idea that that's not the only way. So you can be more creative to develop your own solution. But eventually, we can, of course, get some help from the machines, because nowadays this is the only way to cope with limited time, limited resources, and all the other stress issues that we have nowadays, right? So this was the summary of the talk, and thanks for listening to me. Jose, are you muted? I can't hear you.
Wait, I was.
Yeah.
So
Okay.
thanks so much. Thanks so much. It was very nice. I hope you like it too. So,
Thank you.
my dear, so let me see. There is no questions there. So we have some few people talking or seeing the AgileTD After Work, and yeah, thanks so much for being there for your presentation, and I hope to see you next year at the Agile Testing Days.
I hope so. Thank you so much. Thanks for hosting me. It was my pleasure.
Okay, bye bye.
Bye bye.